Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 4.2, Problem 7. This is Section 4.2, Problem 7. It says maximize z equals 10x1 plus 15x2 plus 10x3 plus 5x4, subject to, and there are two main constraints. The first constraint is x1 plus x2 plus x3 plus x4 is less than or equal to 300. The second constraint is x1 plus 2x2 plus 3x3 plus x4 is less than or equal to 360. And then under that you have x1 is greater than or equal to 0, x2 is greater than or equal to 0, x3 is greater than or equal to 0, and finally x4 is greater than or equal to 0. So to maximize this problem, we need to turn it into a matrix or a simplex tableau and pivot it until we can't pivot anymore, and we'll have the maximum. So in order to turn this into a matrix, I have to change the two big constraints with the 300 and the 360 from less than or equal to's into equals, into equations. And I have to reorganize the object function with the z so that all the variables line up. And I don't have some equations with variables on the right and some equations with variables on the left. So to start that off, I'm going to take the constraint x1 plus x2 plus x3 plus x4 is less than or equal to 300. I'm going to change it into an equation. And it will become x1 plus x2 plus x3 plus x4 plus s1, I'm going to leave a space, equals 300, instead of less than or equal to 300. Then the second constraint that has the 360, it was x1 plus 2x2 plus 3x3 plus x4 is less than or equal to 360. I'm going to change that into an equation also from an inequality. It's going to become x1 plus 2x2 plus 3x3 plus x4 plus, I'm going to skip over a little bit of a space, plus s2. I can't use the same slack. One has an s1, one has an s2. And now it's going to be equal to 360 instead of less than or equal to. Now, the very bottom constraints with the greater than or equal to zeros, x1 is greater than or equal to 0, x2 is greater than or equal to 0, x3 is greater than or equal to 0, x4 is greater than or equal to 0, does not have to go into my simplex tableau. I need to see that they're there. I see them, don't need to put them in the tableau. The object function, however, does have to go in the tableau. The z equals 10x1 plus 15x2 plus 10x3 plus 5x4 has to go into my matrix. And it is an equation already, so it does not need a slack, but I'm going to have to put all the x variables on the left side of the equation now to make them line up with the other equations that I'm going to be putting into my matrix. So my object function has a 10x1 on the right-hand side of the equal sign. The 10x1 must move to the left side of the equal sign, which it can do, and when it does, it will become a negative 10x1. The object function also has a 15x2. That 15x2 originally appears on the right side of the equal sign. I need it to be on the left side of the equal sign, which is going to change it into a negative 15x2. And my object function also has a 10x3, which originally in the problem appears on the right side of the equal sign. Again, I can change that easy enough. I need the 10x3 to go to the left side of the equal sign to make it line up with the other x3 variables. And when I move it to the left side of the equal sign, it'll become a negative 10x3. And finally, there is an x4 in my object function. I have 5x4 at the end of the object function. Like the other x variables, it's on the right-hand side of the equal sign, which is fine when it's written as an equation, but as a matrix, again, all the variables have to line up. So that 5x4 in my object function has to move to the left side of the equal sign so it can line up with all the other x4 variables in the other equations. So to move the 5x4 from the right-hand side of the equals to the left side of the equals, it'll become a negative 5x4. Plus, and again, I don't need any slack variables because I don't need to convert the object function from an inequality. It already is an equation. But I do need to account for the variable that's in it, the z. So after the slack variables, like to the right of those in the last equation I'm writing, I'm going to put a z equals, and now what it equals to after I've moved everything in the object function to the left side, what's left on the right-hand side is a 0. Now the problem is written as a group of equations, not inequalities, and the equations are written so that all the variables line up. Now I can turn it into a matrix or an initial simplex tableau. So when I do that, I'm going to have a column for each x variable. So I'll have to have an x1 column, an x2 column, an x3 column, an x4 column. I have two s's in my equation, so I'm going to have an s1 column and an s2 column. I'll need a column for the z that came from the object function. And I'll need a column for the values on the right-hand side of the equal sign, which I will label RHS. So the first equation that I have was x1 plus x2 plus x3 plus x4 plus s1 is equal to 300. It's going to go into my matrix. The x1 column will just get a 1. The x2 column will get a 1. The x3 column will get a 1. The x4 column will get a 1. The s1 column will get a 1. S2 has a 0. Z also has a 0. And the right-hand side value is 300. Now I have a second equation in my group of equations, which is x1 plus 2x2 plus 3x3 plus x4 plus s2 is equal to 360. That's going to become the second row of my matrix. And the x1 column gets a 1, the x2 column gets a 2, the x3 column gets a 3, the x4 column gets a 1, the s1 column gets a 0, the s2 column gets a 1, the z column gets a 0, and the right-hand side column gets 360. So now I have one last equation, a third equation, which came from my object function, which was negative 10x1 minus 15x2 minus 10x3 minus 5x4 plus z equals 0. That's going to go in as the third row or bottom row of my matrix or initial simplex tableau. The x1 column will take a negative 10. The x2 column gets a negative 15. The x3 column gets a negative 10. The x4 column gets a negative 5. The s1 column gets a 0. The s2 column gets a 0. The z column gets a 1. And the right-hand side column gets a 0. So now I have an initial simplex tableau. Now I need to find the correct pivot and pivot this tableau and see if I have the maximum or if I have to pivot again. So to find the pivot, what I need to do is find the most negative value in the bottom row. So I have several negative values in the bottom row. I have negative 10, negative 15, negative 10 again, and negative 5. Well, of those choices, negative 15 is the most negative. The negative 15 occurs in the x2 column. So the x2 column is going to be my pivot column. Some value in the x2 column will be the pivot value. Now, there's two numbers in the x2 column that could be my pivot. There's a 1 in the top of the x2 column or a 2 in the middle of the x2 column. There's a minus 15 at the bottom of the x2 column. My pivot can never be negative. I don't even consider the minus 15. So for the one of the two, what I need to do is find the smallest positive ratio of right-hand side value over pivot column value. So in the top row, the right-hand side value is 300, and the pivot column value is 1. 300 over 1 is 300. And in the second row, the right-hand side over pivot column ratio is 360 for the right-hand side, over 2 for the pivot column value. 360 divided by 2 is 180. So I have to determine which ratio is the smaller positive ratio, 300 or 180. Well, 180 is smaller. They're both big, but 180 is the smaller value. That 180 came from the 2 that's in the center of the x2 column. So the 2 is my pivot. So I need to turn that 2 into a 1 and then zero out the rest of the x2 column. Now, if you notice, there is a 1 in line with that 2. And if we were just solving the matrix, I could swap row 1 and row 2 and make the 1 show up in the position I want. But in the simplex tableau, you can't do that. You actually have to convert a 2 into a 1, you have to multiply the entire row by 1 over 2. So we will make some fractions. There'll be halves, which aren't too bad. We can deal with that. So let me move over a little bit to the right, and I'm going to set up my next matrix. I'll put the column headings in again, and I'm going to turn that 2 into a 1 for the second tableau. So I have an x1 column, an x2 column, an x3 column, an x4 column, an s1 column, an s2 column, a z column, and RHS. Now as I make the next tableau, the previous tableau, row 1 isn't going to change at this point, so I'm just going to copy row 1 the way it is. x1 gets a 1, x2 gets a 1, x3 gets a 1, x4 gets a 1, s1 gets a 1, and now s2 gets a 0, z gets a 0, right-hand side gets a 300. Now, row 2 has a 2 in the x2 column, which is that 2 needs to become a 1. So I'm going to make a new row 2. I'm going to write an equation next to row 2. I'm going to do row 2 equals 1 over 2 times row 2. So remember, when we make a 1, I just multiply a fraction times the entire row. When I make zeros, I add the rows together. So I'm going to multiply 1 over 2 times the entire row 2 of the previous tableau. So in the x1 column, it's 1 over 2 times 1, which is 1 over 2, or a half. In the x2 column, I'm going to do 1 over 2 times 2 is 2 over 2, which reduces to 1. In the x3 column, I'll do 1 over 2 times 3, which is 3 over 2, or 3 halves, or 1 1/2. Simplify it, 1 over a half is the same as 2 times row 1. That'll be easier to figure out. And it's the same. So if I do 2 times row 1, I'll get the 1 in the pivot position. So 2 times row 1 in the x1 column is 2 times a half, which is 1. In the x2 column, it will be 2 times 0, which is 0. In the x3 column, it's 2 times negative a half, which is minus 1. In the x4 column, it's 2 times a half, which is positive 1. In the s1 column, it'll be 2 times 2 times 1 rather, which is 2. In the s2 column, it'll be 2 times negative a half, which is minus 1. In the z column, 2 times 0, which is 0. And in the right-hand side column, 2 times 120 is 240. And now for the rest of the tableau, row 2 and row 3 will not change because the first part of it is just getting my 1. So row 2 will stay exactly as it is. So in the x1 position is a half, the x2 position is a 1, x3 position is 1 1/2, x4 position is a half, S1 position is a 0, S2 position is a 1/2, Z position is a 0, and right-hand side position is a 180. And the same type of thing for my third row of this particular tableau. It's not going to change yet. It'll start changing when I make the zeros, but for now, in the x1 position, I'll have negative 2 1/2. In the x2 position, I'll have a 0. The x3 position, I'll have a 12 1/2. In the x4 position, I'll have a 2 1/2. In the S1 position, I'll have a 0. In the S2 position, a 7 1/2. In the Z position, a 1. And in the right-hand side position, a 2,700. And I'll keep a circle on my pivot position just because it's such a big, big matrix. I'll do the next tableau. Again, I'll alternate the color. I'll go back to red. So now as I complete the next tableau, which I'm hoping will be my final tableau, the top row has a 1 in the pivot position. So I don't want the top row to change at all. I'm just going to copy that top row as is. X1 will have a 1, X2 will have a 0, X3 will have a negative 1, X4 will have a positive 1. S1 will be a 2. S2 will be a negative 1/2. Oops, negative 1, sorry. Z will be a 0, and right-hand side will be a 240. Now, the x1 column, every other value other than the pivot has to become a 0. So in the second row down in the x1 column, I have a positive 1/2. It has to become a 0. So I'm going to write an equation next to my row 2. It will be row 2 equals some stuff plus the old row 2. Now, I start that equation with row 2 because that's the row making the 0 in. I end the equation with row 2 because the equation should begin and end with the same row. What I call stuff is the row with the pivot position, which for this problem is row 1 now, times the same number opposite sign as what's becoming a 0. So what's becoming a 0 is a positive 1/2. So the same number opposite sign is negative 1/2. So the equation that I'm going to use to make my new row 2 is row 2 equals negative 1/2 row 1 plus the old row 2. And now do that to every value in row 2. So in the x1 column, negative 1/2 times row 1 is negative 1/2 times 1, which is minus 1/2 plus row 2. So minus 1/2 plus positive 1/2 makes an answer of 0 for x1. In the x2 column, negative 1/2 times row 1 is negative 1/2 times 0, which is 0. Add that answer to row 2, so I'm going to add 0 plus 1 is 1. And the zeros are very nice to work with. Next, the x3 column. I'm going to do negative 1/2 times negative 1 is positive 1/2, right? Negative times negative is positive. So take that answer of positive 1/2, add it to row 2. So I'm going to have positive 1/2 plus 1 1/2 is positive 2. And the next column, the x4 column, negative 1/2 times row 1 is negative 1/2 times 1 is minus 1/2. Plus what's in row 2, so I'm going to add negative 1/2 plus positive 1/2 is 0. Actually, a lot of the fractions are starting to go away. The next column is the S1 column, so I'm going to do negative 1/2 times row 1 is negative 1/2 times 2 is minus 1. I'm going to add that minus 1 to row 2, so I'm going to add minus 1 plus 0, which is minus 1. Next, in the S2 column, I'm going to do minus 1/2 times minus 1 for minus 1/2 times row 1. So negative 1/2 times negative 1 is positive 1/2. Again, remember, negative times negative, they cancel. Positive, so you have positive 1/2. You're going to add that positive 1/2 to what's in row 2. So you're going to add positive 1/2 plus another positive 1/2 is 1. In the Z column, negative 1/2 times row 2 is negative 1/2 times 0. Add that 0 to what's in row 2. So you're going to do 0 plus 0. It's an answer of 0. And finally, in the RHS column, negative 1/2 times what's in row 1 is negative 1/2 times 240. So negative 1/2 times 240 is negative 120. And add that negative 120 to what's in row 2. So you're going to add negative 120 plus 180 is positive 60. So that completes one of my rows, one of my zeros that I need to make to finish pivoting my x1 column. The next zero in the very bottom of the x1 column is currently a negative 2.5, so I need to zero that. So that negative 2.5 is in row 3, so next to row 3 I'm going to make an equation, row 3 equals some stuff plus the old row 3. Now, I start the equation with row 3 because the value I need to zero is in row 3. I end the equation with row 3 because it should begin and end with the same row. Now, what I said was stuff is the row with the pivot point, which for this problem right now is row 1. That's the row with the pivot point. And it's going to be multiplied times the same value but opposite sign as what's becoming a 0. So what's becoming a 0 is negative 2.5. So the same number opposite sign is positive 2.5. So the equation I'm going to use for my new row 3 is row 3 equals positive 2.5 times row 1 plus row 3. And let's see what that's going to give us. So in the x1 column, 2.5 times row 1 is 2.5 times 1. So that's positive 2.5. Add that answer to row 3. So positive 2.5 plus negative 2.5, 0. The x2 column, 2.5 times row 1 is 2.5 times 0. That gives me an answer of 0. Add the 0 to row 3, so I'm going to add another 0. I do 0 plus 0, I get an answer of 0 for the x2 column. Next column is x3, so I'm going to do 2.5 times row 1 is 2.5 times negative 1, which is negative 2.5. I'm going to add the negative 2.5 to row 3, so I'm going to add negative 2.5 positive 12.5 is positive 10. Next column, I'm going to do 2.5 times row 1 is 2.5 times 1, which is 2.5. I'm going to add that to row 3. So I'm going to add 2.5 plus another 2.5, right? They're both positive. So that's going to add up to 5. And then the next column is the S1 column. So I'm going to do 2.5 times row 1 is 2.5 times 2. That's 5. plus row 3. So I'm going to do 5 plus 0. 5 plus 0 is 5. The next column, 2.5 times negative 1, 2.5 times row 1 is 2.5 times negative 1, negative 2.5. Negative 2.5 plus row 3 is negative 2.5 plus 7.5. So it makes another positive 5. In the z column, 2.5 times row 1 is 2.5 times 0. That's 0. Add that to row 3, so I'm going to add 0 plus 1. Gives me a 1 in the z column. And finally, in the RHS column, 2.5 times 240. I think that's 600. Let's check it. So I'll go 2.5 times 240 is 600. So 2.5 times row 1 is 2.5 times 240, which is 600. You're going to take that 600 and add it to row 3. So you're going to add 600 plus 2,700 gives me 3,300. And now, as I look at the bottom row, there are no negatives, which is awesome. Very glad there are no negatives. There are negatives in other places, but again, not in the bottom row. So I found the maximum. So again, what happened is my initial tableau had an output of 0, because that was the value in the bottom right-hand position. With one pivot, the output went from 0 to 2,700. And I pivoted again, and then it went from 2,700 to 3,300. And now that I can see that I can't make it any bigger. 3,300 is as big as it's going to go. So let me write the solution underneath again. I'm going to go to a different color. So we can say maximum of 3,300 when x1 equals. Now, in the x1 column of my final tableau, I do have a special column of all zeros and a single 1. So the x1 variable does have a value, a non-zero value. The 1 in that special column in the x1 column is in the top position. So as I look over at the RHS column in the top position, I see 240. So 240 is what x1 equals. x2. So the x2 column of my final tableau does have a special column of all zeros and a single 1. So it has a non-zero value. So the 1 in that special column is in the middle position. So as I go to the middle position of my RHS column, that middle height I have a 60. So that's the value of x2. x2 is equal to 60. x3. In my final tableau, the x3 column does not have a special column of all zeros and a single 1. So its value is 0. And the same will be true of x4. When I look in my final tableau, the x4 column does not have a special column of all zeros and a single 1. It's got some other stuff, so its value is 0. As usual, you do not have to say the value of the slack variables. You can if you like. It's optional. It's good practice for us. In the final tableau, the S1 column does not have a special column of all zeros and a single 1, so the value of S1 is 0. Same is true for S2. The S2 column of the final tableau does not have a special column of all zeros and a single 1, so S2 is also equal to 0. So the final answer, you get a maximum of 3,300 when x1 is 240, x2 is 60, x3 is 0, and x4 is also 0.